Good afternoon, everyone. This is Rahul Mangharam here. I'll give you a very brief update on the work that we are doing at the University of Pennsylvania. Unfortunately, I'm traveling today, so I just thought I'll do a quick recording. So, uh, very briefly, one of our top projects that were going on in the past year was on, development of different platforms where we have autonomous driving capability. And that's from 1/10 scale platforms that we've had with the F110. Now, the main thing that we wanted to do, right, was to actually homogenize this by having the same software stack and the same software architecture that runs on 1/10 scale platforms, then that runs also on half scale, the autonomous go-kart platform that we've been developing. And now we're transitioning that to running also Autoare on a lot of, off-street logistics vehicles, electric vehicles. And so now that we have a training program with F110, and then a whole vehicle, an electric vehicle building program with the go-kart, these are all completely open source. Autoware is the world's leading open source autonomous driving software. And now that is powering a lot of different platforms for logistics, cargo, and last mile delivery. And so we are focusing on developing this kind of stream. We have got Autoware running on the F110 platform. We'll actually be demonstrating that in the deployment partners deployment meeting in November, where we'll have F110 is autonomous racing course that is also now being taught at CMU. So we'll have CMU students, in addition to Penn students, demonstrate this capability. Through this, we also have now developed a very interesting network of faculty across the globe called the Autoware Center of Excellence. And this has over 22 faculty partners. All of them use Autoware as a software stack in their own research vehicles. And so this is actually looking at very different research themes from verification, validation, perception across different universities from TU Munich to UCLA to Czech Republic universities and so on. And with each of these partners now, we have very good engagements, and this allows us to actually have our Safety21 research now spread across to many of these universities through the use of the Autoware software stack. And we've had a lot of very good success with organizing competitions. Earlier, I showed we had a competition in London for F110. That was a huge success. Now, just earlier in October, we had one in IROS, which is a robotics conference in Detroit. And there were lots of teams. There was really, really fun, exciting race. The Autoware teams that were running Autoware stacks, they won the second and third places. And then the first place was actually won by a set of undergraduates from University of Laval in Quebec City. And it was a very, very exciting race. It was the center of the whole conference. We also had a F110 competition in South Korea in the middle of October, and that had 31 teams. 29 teams ended up competing, and it was such a huge event. And with you can see all the teams here with their F110 cars with different algorithms. So all teams come with the same reference vehicle design that we have shared as part of our Mobility 21 project. And now this has become a national program in Korea with over 20 plus universities that have funded their teams and will also be doing this in the next 2 years. So they have a plan for that. And they do this at a very large scale. We also had our Safety21 research be presented by Pojan Wang in Ross by the Bay. The Ross is a robot operating system, and this community now is mentored and nurtured by Intrinsic, which is a Google company. And so they have a lot of interest in using the automotive and autonomous software in different types of vehicles. And there are a lot of different, our coursework and our different projects that we have developed as part of Safety21 were all, and Mobility 21 were all demonstrated over there. We also had many different partners from ARM and from Gifu University and from Pix Moving with different electric vehicle chassis at IROS. And this is new developments that we will have. of called software-defined vehicles, where we will be designing and testing and deploying vehicles from AWS in the cloud using ARM processors. We also received a Yamaha EV chassis. This actually has a LiDAR on the top here, you can see. And then we have LiDARs, 3 LiDARs in the front, and this is used for intra-logistics. And we have also Professor Sanjeev Singh, who visited us from CMU during this demonstration of 110 scale, half scale, and then these logistics vehicles. It's all starting to come together. We also have some partners from Wharton University, and I'll talk about the involvement we have with them. We also hosted a very exciting workshop called Mad Games on multi-agent dynamic games. And the goal here is to sort of come up with different vehicle driving strategies so that we can realize safety through agility in these very adversarial games. And so how do you navigate an intersection, roundabouts, and also very risky situations? How do you think about risk when you're designing these vehicles? And so the road ahead over here is, part 1 of 3 years to look at, how can we have safety through agility, but for movement of goods. So in warehouses and in what are called cross-dock systems, how can you have a large number of robots cooperate and also operate at very high speeds? Then we also have projects in localization. So this is because for any vehicle to be able to perform well on the road, it has to know where it is. We've come up with very new algorithms that were presented at ICRA earlier this year, where we actually can localize the vehicle using a neural network, but a special type of neural network called an invertible neural network. I won't go into the technical details, but I'll just show that it's very fast, operates at over 270 Hertz. It's very accurate with less than 0.2 meters error in a city scale level. And this is regenerating the entire map from the neural network. And here it can also work with images. And as it's driving through, none of these images are real images now. They're all generated by the neural network searching for and identifying where it is in the map. I can share more details on that when we have a more technical discussion. Lots of other projects are going on. Very briefly, we are exploring traffic signal networks using graph neural networks and differentiable neural networks and optimization with DVRPC in Philadelphia. There's a project with railroad track inspection systems with SEPTA that we've started to look at. Driver's education program, which Helen Loeb will talk about much more. Autonomous vehicles for logistics and the business case for that with the Wharton School, but using open source software. Community platforms for education, now moving to larger scale vehicles, but standardized open source vehicles. And then finally, high fidelity simulated driving in Philadelphia roads with Eric Guerra and Helen Loeb as a joint project. So I'll stop here, and I'm sorry I couldn't be there in person, but I hope this update was useful. Thank you.